Hi, welcome back. Just wanted to do a quick little video to show you how we're going to calculate things tomorrow for class. So we have modeling of the angle of the sun. So we're going to talk about this angle, which we're going to represent here as sunrise, sun directly overhead, and sunset. Now, typically we think of sun directly overhead is at noon, but if you remember that the sun is also tilted, or the Earth is tilted in relation to the sun, it's not always that noon is straight up unless we're at a couple of the special times of year where that happens. So we have a bunch of things in this formula that we need to understand. Again, theta will be 0 at sunrise, pi halves when the sun's directly overhead, and then as we go closer over here. So pi halves is directly overhead 90 degrees. Radians, the Earth rotated since noon. So the Earth rotates around on its axis as well, as which helps us in relation to the sun, and we needed to convert that rotation into radians. I'm going to leave that for you to do tomorrow in class. I mentioned it today, and hopefully you'll understand and be able to calculate that using some of the hints I gave. D is the declination of the sun. That has to do with the rotation, the tilt of the Earth, and as we go around the sun is at different places. It's not always directly over the equator. It's only over the equator twice a year. So that's the declination of the sun. That's what gives us our seasons. And then L is the latitude of where you're on Earth that you're trying to make this calculation. So let's go through one and see how we all plug it in. So first of all, you have to look at the latitude of where you live on Earth. So Sacramento, California has a latitude of 38.5 degrees, which is also north because it's above the equator. So we're going to find the angle of the elevation of theta at 3 p.m. last February 29th, 2012, where at that time the declination was that many radians, negative 0.4125 radians, and the Earth had rotated 0.7854 by 3 p.m. So we'll go ahead and take our formula, use our formula. We got to plug all these things in. So we know D, we know this funny looking W thing, we know L is 38.5, although this is in degrees, and we'll need to convert that into radians because everything else is in radians, and this formula is going to need us to use radians. So we'll go ahead and take a minute and plug everything in. So as we do that, we'll get something that looks like this. So we plugged in D. I did the conversion here without actually doing the conversion. That's 38.5 times pi divided by 180 because that'll convert it to radians. And then we'll take the cosine of the 7854, the W thing, and we'll have these two as well, straight from the information that we were given. This calculates to this. So we'll go ahead and take that, and if you plug that all in the calculator, take a look at the calculator. I typed this in already because there's a lot of typing. I'm going to keep this video short. Typed in exactly what I have here. Again, this number comes from the 38.5 times pi divided by 180. And if I hit enter, I'll get that this is 0.45936 something, 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 something. So that tells us what we have, but that is in radians. And we need to convert that radians into degrees. So we'll have to go ahead. Oh no, first we have to find the sine. We have to find what that is in terms of the radians. We know what the sine of the angle is. We just don't know what the angle is. So we'll take the inverse sine of both. We'll do that in our calculators. We'll do the inverse sine of our previous answer, and we'll get that we have 47.772786. That is the number of radians that the Earth has rotated. Now, that doesn't do us a lot of good because most of us can't think in radians, so we'll go ahead and convert that back in. It says they want the angle of elevation. They gave us that angle in degrees, so we'll go ahead and convert this degrees. We'll do the opposite here. We'll divide by pi and multiply by 180. So we'll divide by pi and multiply by 180, and we'll get 27.3 degrees. 27.3 degrees. So it's up here in the sky at about just before 30 degrees at 3 p.m. Now, that doesn't make sense because at 3 p.m. the sun can't be rising over here. So the sun's really past the 90 degrees. There's another angle that's equivalent to that over here. And is the sign positive or negative in this quadrant? If we put in our other axes here at 90 degrees. Oops, that's not an axis. Go ahead and put an axis in here. at 90 degrees, the x-axis. So we can see that while we have approximately one that is right here, and it's cosine comma sine, we're moving up for sine, there's an equivalent angle over here for where the sun would be. So the sun really isn't at 27 degrees at 3 p.m. and that doesn't make sense. The sun cannot be at 27 degrees just barely above sunrise all the way before the sun is setting here at 3 p.m. in the winter in Sacramento. So we have to go ahead and figure out what does this mean. So this angle here is 27 degrees. It's 27 degrees back from 180. So that will mean we're going to take 180 and minus the answer we had to give us that this is 152.6 degrees is the actual length or rotation that the sun has gone through. So if we go ahead and look, it would be exactly or approximately 152.6. 152.6 degrees according to the directions they gave us. So there you have the answer that you can put in the paper. So the idea tomorrow will be you'll be doing this for your birthday. Hopefully you thought about this. Maybe ask your parents tonight what time they think you were born, if they can remember, or if not, I'll tell you what time to use. But we'll see what we can do, because the time of year will affect both the declination of the sun, where you were born will be affected by your latitude, and then the radians the Earth has rotated since noon will also be affected by when you were born. So we'll go ahead and leave it at that for now. Hopefully this makes some sense and you can understand that we're over here now, and this is what we need to figure out. The sun has gone all the way through. It's about 27 degrees above the horizon in the west part of the sky. Have a great night. Thanks.